In this video, we will discuss the problem non-overlapping intervals. So the problem basically says that we'll be given a 2D array of intervals where the first part of the ith interval represents the starting of the ith interval and the second part represents the ending of the ith interval. For example, if we have been given a pair 1, 2, so 1 is representing the starting part, 2 is representing the ending part, and same goes for the rest of the intervals also. Now the question says that we have to return the minimum number of intervals that we need to remove to make the rest of the intervals non-overlapping. So let us understand what do we mean by overlap here. Suppose that we have got two intervals. Let's say we have got one interval like 1, 7 and another interval is, let's say, 5, 10 here. Now do these two intervals overlap? Yes, these two intervals definitely overlap. Now, why do they overlap? Because you can see that the ending time of this interval is greater than the starting time of the next interval. So that is why these two intervals will definitely overlap with each other. So such intervals will be called as overlapping intervals. Also, one more thing, if there is an interval which is like 1, 5 and another interval is 5, 10. So suppose you have got one interval 1, 5, another interval is 5, 10. Now these two intervals do not overlap. Why? Because like this interval is ending at 5, another interval starts as 5. So in this problem, we'll not consider this as an overlap here. Okay. So let's see the first test case here, like how we are counting the final answer. So if you will see, the first test case is basically 1, 2. Then we have got what? We have got 1, 3 also. Okay, then we have got 2, 3. So I'm writing this in the sorted format of ascending order. Why? So that we can iterate for the intervals from the starting till the ending in a number line format. So then we have got this and then we have got this interval. Now if you see here, what will happen is when I'll look closely at the first and the second interval. So first interval is 1, 2, second interval is 1, 3. Now you can see here that there is an overlap. Why? Because I can definitely say that this interval is ending at 2 and the next interval is starting at 1. So this means that before the first interval ends, the next interval is also trying to start. So this is an overlap. Now since this is an overlap, so I'll consider this as the very first overlap here. Okay, so I'll consider it as an overlap. Now if you consider this as an overlap, later on this interval and this interval will not be overlapping. Correct? Why? Because I've told you that if for overlap condition you need to have the end time of the previous interval being greater than the start time of the next interval. But here the starting and the ending is same, 3 and 3. So that is why this will not be considered as an overlap. Now what are the various ways of solving this problem? First way you can understand is obviously the sorting approach will be used here, but the very first way of sorting would be to arrange the intervals in the ascending order of the starting time. Because if you arrange the interval according to the starting time, then what will happen is you will be able to iterate through the intervals from the left to right direction in the number line. Okay, so let's see what we can do here. If you will sort the intervals according to the starting time greedily, then this will help you to minimize the count of the overlapping intervals. Now how will this happen? So first we can sort the intervals by their starting values. So initially you can sort the intervals based on the starting values, then you can traverse the interval, then you can do what? Then you can traverse the array and check if any interval has a starting point smaller than the ending point of the previous interval. That is, there is an overlap. In case there is an overlap, then remove the interval with the greater endpoint. Now this is also important. If you will see here, so initially let's suppose that I'll start from this particular interval. Now what will happen here? My current ending will be what? My current ending will be basically 2 because I'm starting from this interval and initially there is no overlap, so I'll mark the count initially as 0. Now when I go to the next interval, so what do I see there? I see that this interval has got a starting which is lesser than my ending. So current ending is 2. So the interval is ending at 2, but the next interval, that is the ith interval, is starting from 1. So this means that there is an overlap. So since there is an overlap, so I need to increase my counter. I'll increase my counter to 1. Now after this, I can observe that this is an overlap. Now should I update my ending as 3 or should I keep my ending as 2 only? The thing is that if you read the approach here, so we should do what? We should keep the ending we should keep the lesser ending with ourselves. Why? Because if these two intervals are overlapping, then I'll say that okay, if they're overlapping, so let's consider this as 1 comma 2 interval. Why should we consider this as the interval 1 comma 2? Because if you will consider the lesser ending here, in such a case you are saving more time, you're giving more time to the other intervals such that they do not overlap. Because if you choose a higher ending point, what will happen is that higher ending point might overlap with a lot of future intervals. But if you choose the lesser ending, suppose if you choose 2 here, which is the lesser ending, in such a case the ending is lesser, so chances of overlapping with the future intervals will be also lesser. So that is why we are iterating after sorting in the ascending format of the starting time. And then after that, what we are doing is we are looking at the overlaps. Whenever there is an overlap, so we increase the counter and we make sure that we are updating our current ending to the minimum of the two intervals, that is minimum of the end time of the current interval as well as the ith interval. Why we take the minimum? Because if you take the minimum, then what will happen is, if you take the minimum, then chances of overlap with the future intervals will be lesser. But if you take the maximum one, then chances of overlap of that interval with the future intervals will be higher. So that is why you should choose the minimum. So now you can assume that you have got 1 comma 2 here instead of these two intervals. Now what will happen here is, next up you'll go to the next interval. Now does it overlap? Because for overlapping, the condition is that the starting should be less, but here the startings are equal, so they are not overlapping. Because for the condition of overlap, we need to consider that the current ending is basically greater than the starting of the next interval, but that is not so here. So that is why there is no overlap here. So what we will do is, we will say that okay, if there is no overlap, then the current ending will update to the ending of the ith interval, that is 3 here, because the ending of this particular interval 2 comma 3 is 3 only. Then we'll go to the next interval. The moment we go to the next interval, now we are at 3 comma 4 interval. So we will check what, when we'll come across this, we'll check if the current ending is what, if the current ending is greater than the starting of the next interval. So that is not so. So that is why we'll not consider this as an overlap, and we'll say that this is fine, there is no overlap here. So we'll move to the next one. Now when we move forward, then we do not have anything, and you can understand that the count is still 1 because there was only one overlap. Why there was only one overlap? Because we considered the lesser for these two intervals which were overlapping, we considered the lesser ending. If we would have considered 3 also, then this interval 2 comma 3 would have also overlapped. So that is the advantage that we got by taking the lesser endpoint and ignoring the interval with the greater endpoint while merging, or while considering the two overlapping intervals. I hope you have understood this. Now this would take how much time complexity? Since you'll be sorting the intervals, so sorting would take order of n log n time, and we will not take any extra space. So that is why space complexity would be order of 1. So let's write this. Time complexity for this approach would be n log n here, and the space complexity for this particular approach would be order of 1. I hope that this approach is clear so far with respect to sorting by starting time. Now let's have a look at the code also. So you can see here what will happen is, initially the count will be equal to 0. Okay, then we are sorting according to the starting time. We have sorted according to the starting time. Then initially the ending is equal to the ending of the very first starting interval, the 0th one. And we'll iterate. If what happens is, if the ith interval that I'm at, if it is having starting less than the current ending, in such a case we need to update the counter, and the ending will be updated with the minimum of the ending of the two intervals. Whichever is the minimum of the two overlapping intervals ending, will take the minimum of that, as I have told you. Then otherwise, if there is no overlap, then you can update the end directly to the end of the ith interval. And then after this, what will happen is, we can simply return counter here. So this is how we can code this problem up. I hope you have understood basic code here. Now after this, let's consider the case where we can basically do what, we can solve this again using sorting, but here we can sort according to the ending time. Now why sorting according to the ending time would work? Because the idea is that we'll try to greedily keep the intervals sorted according to the earliest ending. If you arrange the intervals according to the earliest ending, in such a case, what will happen is, you will be considering those intervals which have lesser ending time. And if you consider those intervals which have lesser ending time, then you have more room, you have more space for the future intervals. So chances of overlapping would be less here. So that is why will try to consider those intervals which have lesser ending time. So we'll iterate on those intervals which have lesser ending time, whose end time is lesser, because if you consider those intervals whose end time is lesser, in such a case you get more time for the you get if you consider those intervals which have lesser ending time, then those intervals are ending earlier and you get time for the future intervals, because there will be no overlapping. If you consider lesser endings, then chances of overlapping with the future or the subsequent intervals would be less here. So to consider this approach, think of it as trying to keep intervals short so that we can have more space for other intervals without overlap. By sorting according to the end time, we can easily check if the next interval overlaps with the previous one. If there is an overlap, then we can remove the interval with the later end time. So basically, if there is an overlap between two intervals, you need to consider that interval which is having lesser ending time. Okay, so that it does not block the future intervals, it does not overlap with the future intervals, and this way we can end up with the minimum number of intervals that we need to remove. Okay, so basic intuition is that greedily we keep the intervals that end the earliest, such that this will help us to have more space for the future intervals, and chances of overlaps will be lesser if you consider those intervals with the lesser endings. Okay, now if you see, so let's say we have this particular test case here, and we will basically sort it according to the lesser ending time in the ascending order of the ending time. Now what will happen here is, in this case the count would be equal to what? 0. Okay, and the current end would be what? The current end would be, let's say, 2 here. Now after this, when we'll start with this interval, now is there any overlap? No, because if you see the starting of this interval, is it less than the current ending? No. So that is why what we can do is we can proceed further, and we can say that the ending will be updated to the ending of this particular interval. So ending will be updated to 3 here. So let's update the ending to 3. Then after this, what will happen? We'll move to the next interval, that is the interval 1 comma 4. Now when we come to this interval, so is the starting of this interval lesser than the current ending? Yes. So this means that there is an overlap that we are considering here. Now the moment we consider an overlap, so the count will be updated to what? The count would be basically updated to 1 here, and then after that the ending will be the minimum of the two endings. So minimum of 3 and 4 will be nothing but 3 here. Why we take the minimum always? I've told you already, because if you take the minimum ending out of the two overlapping intervals, then chances of overlaps with the future intervals would reduce, and we need to make sure of that. Now after that, we'll go to the next interval, that is 3 comma 5. Now current ending is 3 and the starting is also 3, so we will not consider this as an overlap, because overlap will be considered only when the start time is lesser than the current ending. So this is not there, so that is why the count will still remain 1 here, and the current ending will be 3. So you can see here that by removing one interval, we will be able to complete our job here. Now let's consider the code also. So if you will see here, again we have to do what? We have to mark the counter as 0, and we are sorting according to the ending time. So we are passing key is equal to lambda x colon x x1. So this indicates that we are sorting according to the ending time, descending order. Now after that, initially the ending will be updated to the ending of the very first interval, and then we'll iterate. So if the starting of the ith interval is less than the ending, then we increase the counter. Okay, otherwise what you will do is you will update the ending to the ending of this ith interval. If there is no overlap, then you update the ending to the ending of the ith interval. So this is how you can code it this way. The time complexity for this code would be order of n log n here, because we are sorting, and the space complexity would also be order of 1, because we are not using any extra space. Let's code the very first optimal approach, that was sorting according to the starting time. Okay, and submit it also. So yeah, let us submit this code now. So you can see that the code is also getting accepted. I hope you have understood this. Make sure to mention your feedback in the comments. Thank you for watching this video.